Up next we have Jess Vaccare. She graduated this past spring from the State University of New York College of Environmental Science and Forestry, SUNY ESF, with a degree in environmental science and a concentration in watersheds and a minor in marine science. She has been working here in Newport this summer with the EPA, and one of Jess's goals this summer was to go to the beach at least twice a week. So it sounds like the scholars in their personal goal making were really trying to take advantage of their position on the Oregon coast this summer.
All right. Hi everyone, my name is Jessica Vaccare, and this summer I worked with the EPA, and we wanted to assess the hydrology and soil characteristics of the salt marshes up in Tillamook Bay, Oregon. So just a really quick background, I was working with the Ecosystem Services Research Group, and we wanted to look at the ecosystem services of these salt marshes. So the one in particular that we were kind of focusing on was how these salt marshes were removing excess nitrogen. And one main way that this is done is through denitrification, which is basically when the salt marsh would take up active nitrogen from the water and release it back into the atmosphere as nitrogen gas. Now, in order for that to take place, there has to be anoxic conditions, which is little to no oxygen left in the water, a source of nitrate, which we think is possible since this is a very heavily agricultural area, and then also a carbon source. And I'll talk more about those later. But in order to look at this denitrification, we have to analyze the hydrology of these systems. And in order to do that, we have to look at the soil characteristics. And also, we think the distance from the main channel you are from in the marsh has a huge impact on how this water flows through the system, which is why at our two sites, Dike and KPR, you can see we have, now they're really small, but we have transects in here with 4 different well points. So just a quick overview of the methods. We went to the two sites you saw before and put in one transect with 4 wells. So we took soil cores at each of these wells and brought them back to the lab and analyzed them for the percentage of sand, silt, and clay. And we also put in these PVC wells, which with hobo data loggers, which basically tracked how the water moved up and down in the well, and then we could infer from there how water flows through the system over time. And I'm just going to kind of go over quickly some of these graphs because I think they're important. But if you can pay attention to the left, to the y-axis, it's actually the depth. So at 0, that's the surface of the marsh, and as you go down, that's further into the marsh. So at our KPR site, there's a high percentage of silt, whereas in our dike site, there's a low percentage. And if you inverse these graphs, that's actually the percentage of sand. So if you could just keep in the back of your head that our KPR site ended up being very silty, whereas our dike site ended up being very sandy. And the percent LOI is the amount of organic matter in our samples. So our KPR site had a relatively high amount of organic matter compared to our dike site, which had a relatively low amount of organic matter, which in this case would be the carbons, one of the main carbon sources for our sites. So this is one of my favorite graphs. This is a cross-section of the hydrology during overtopping tide. So this is basically how the water drains. And so if you can imagine the horizontal dark black line is our transects, and the vertical black line is the bank in this channel. So over time, as this marsh drains, you can see that our 2-meter well drains much quicker than everything else as in our other wells in the marsh. And this is because it's a very silty site, so water does drain through it less readily as compared to our sandy site. As you can see, over time, the water does drain in every single one of our wells. And this is the percent inundation, so how long different wells in our sites stayed saturated. So as you can see in our KPR site, the furthest well away from the channel actually stayed inundated longer compared to the wells that were closest. But that trend actually flips at our dike site, where the closer wells to the channel actually stayed inundated longer. And so we think that it is possible at our KPR site that anoxia could occur, but at dike it's probably not going to happen because at the sites the wells that are closer to the channel, these do have the tides coming in and out of it, which probably brings in more oxygenated water. So based on the current data that we have right now, it looks like KPR has conditions that may be more conducive to allowing denitrification to happen compared to the dike site. But in order to look at this, we'd have to actually test for nitrogen and get full oxygen data, which is something that will most likely happen as this study progresses. But what we looked at is basically just a big piece, the small piece of this big project to look at how water flows through these salt marshes and hopefully can be used to help look at the water quality in this area. I would really like to thank everyone from Oregon Sea Grant for helping me fund this project, making the summer possible, and to Jody, Daryl, and Ted, and everyone else at the EPA for being amazing mentors. So, are there any questions?
So, digest for me again, soil type versus denitrification, sandier, worse for denitrification?
Okay, yeah.
Yeah.
So sorry, there's so much stuff and I want to kind of
I just need to
hit
hit
it all.
Yeah.
Okay, so basically for denitrification to happen, it has to have three conditions. So there needs to be a very low to no amount of oxygen left in the system, there has to be a source of nitrate, and there has to be a carbon source. So to look at how, to see if like a site is even, like if denitrification can even happen, there has to be no oxygen. So which is why we wanted to look at the hydrology. If the salt marsh would stay inundated longer, the oxygen would be processed and used up quicker and would most likely be able to go anoxic. So but in order to look at the hydrology, you have to also understand, is it, like what's the soil like? So a sandier site, as you saw in the dike site, the water drains pretty quickly, so it's not going to stay inundated very long. So anoxia is probably not going to be possible. Whereas in the KPR site where it was silty and water drains much slower, there's a much higher chance that anoxia will happen. So that means that there is a higher chance that denitrification could occur there. And by releasing this nitrogen back into the atmosphere, you're basically removing it from the system, which can help improve water quality and just gives an ecosystem value to having a salt marsh there.
Okay. And then so your two different sites, thank you for that, that was helpful.
Yes.
And then your two different sites, do they have different characteristics in terms of what's around them, land use?
Yes.
Or, okay.
Yes, so our dike site, I can actually go back. Okay, so the dike site, you can see it actually is on top of a sand spit, so we kind of expected it to be pretty sandy.
Yeah.
And then to the left of it, there is a dike built, which is why it gets its name, and that's just to prevent the ocean water from coming into this area. And then there really isn't a ton of agriculture here compared to the KPR site. So we did expect this one to have more nitrate available to it. There's definitely in the Zoom, no, I don't have it, but there's all this agriculture area, and there's also a lot more of urban development. So we expect the dike site to be sandier, and we definitely thought the KPR site wouldn't have the same type of soil characteristics, so we kind of just wanted to get two different perspectives in the area.
Thank you. So land use is related to?
Yes,
Good.
absolutely.
Thank you.
Yes.
So you looked at hydrology and soil characteristics essentially as a proxy for denitrification, where you think it might happen. Is there going to be follow-on work to actually look at nitrogen cycling?
Absolutely. That's actually what Daryl Marwa's kind of working on right now, is looking at the nitrogen budget in these salt marshes. We had a very restricted amount of time, and we kind of jumped in at the beginning of looking at the Tillamook site. So the first step was to kind of just see what's there right now. And so Katie and I, the other intern, actually did the nitrification speculation because we were interested in it. So